Hello there, everybody. This lesson is about Newton's method. This is the second half of section 4.5. The first one we did last time. We were approximating values of functions. Here we're doing some approximations as well. Newton's method is a way for us to solve an equation like this. Some function equals 0. This method only works when there's 0 on one side. So if you have an equation you're trying to solve or get an approximate solution for and it's not equal to 0, you got to make it equal to 0. So if it said equal to 2, you got to take away 2 from both sides. You got to have 0 on one side in order to use this. And this is the formula that gives us the solution, kind of a better and better guess, essentially, and I'll show you what that means in a second. But this is something you are going to write down. This is f prime of xn on the bottom. So what the heck does this thing do? So we've got this curve here. This curve is our f of x, and we're trying to find where it equals 0 or where it crosses the x-axis. We're looking for that point right there. So Newton's method always starts with a guess. You just guess, and you try to get as close as you can, but it's not always intuitive about exactly where it might be, where the solution might be, but you do the best you can. So let's say we pick this one as our first guess. So Newton's method takes this x value that we've guessed as our solution, and we're not too far off depending on the scale here, but we make a guess. And then it takes the y value on the curve at that point, and it makes a tangent line. And it follows that tangent line until we get down to the x-axis. And that number right there is kind of our next best guess. You can see we got closer to the point we were looking for than where we started. This is where we started. We went up to that y value on the curve. We followed the tangent line down, and we get to here, which is closer. Now and that's going through this process once. Going through it again, we take that y value, the y value at this new best guess. We follow that tangent line down until we get to the x-axis, and we get even closer. So going through this twice got us to there. And if you continue to do it, you're going to get closer and closer and closer and closer to the actual solution of the equation. So let's see what that looks like. Okay, so let's say we wanted to solve this equation, x cubed plus 3x plus 1 equals 0. I'm going to tell you there's a solution between -1 and 0. That's the solution I want you to try to find. Okay, the first thing we need is a guess. Now I've told you that it's between -1 and 0, so guess a number between -1 and 0. And it doesn't matter what it is. Let's just say -0.5. It's halfway between 0 and -1. In reality, it doesn't really matter, but you do want to try to get close. Weird things happen if you would have guessed like 1,000 or -10,000 or something was too far away. Actually, they won't converge to the actual solution. So you got to be kind of close. Okay. So this is our f of x in that formula that I showed you a minute ago. Notice that it equals 0. We need it to equal 0. If it's not, you got to make it 0. But we do need f prime of x. So let's write f prime of x over here. And so f prime is going to be 3x squared plus 3. Yeah, well, I'll stop there. So 3x squared plus 3. So our next best guess is our first one minus f of -0.5 over f prime of -0.5. Which, if you were to work it out in your calculator, gives you -0.3 repeating. It gives you -1/3. So this is a little bit closer to the actual solution than -0.5 is. So let's do this again. Let's get even closer. So we take our best guess, 0.3 repeating. We take away f of negative 0.3 repeating over f prime of negative 0.3 repeating. And you can check this in your calculator. In fact, I would strongly encourage you to. You get negative 0.32223. And you could keep doing this over and over and over again until the numbers in the calculator didn't stop, and you know that those would be accurate. But what we're getting is closer and closer to the solution of that equation. Now, do you have to write all this stuff out? No. What I do expect to see is this number and this number and this number, your successive guesses. And I'll show you a real easy way in your calculator how to get that. Okay, so you're going to want your calculator out here. I'm going to go to the y equals, delete anything you got in there. In y1, let's put our f of x. In this case, it's x cubed. What was it? Plus 3x minus 1. In your y2, put f prime. 3x squared plus 3. Okay, once you get that, go back out to the main screen. Now, we had an initial guess here of negative 0.5. So I want you to take negative 0.5. Oops, that's 0.05, excuse me. And I want you to store it. So the store button is right above on, but you're going to store that to x. Okay, so we're going to take that negative 0.5 and assign it to that value, x. Now we're going to take x and subtract. Here's the formula that should look familiar. It's f of x over f prime of x. So let's see, we want y1 divided by y2. Now, because we've stored negative 0.5 as x, the calculator is going to think that this x right here in our y1 is actually negative 0.5. And it's going to think that this x over here, this 3x, is actually 3 times negative 0.5. And the same thing down here in the y2. It's going to think that x right there is negative 0.5. Okay, so we'll go back out. Now, before you hit enter, if you leave it like this, it will give you the next guess. But we want to store this value as x. We want it to, because we're going to do the exact same thing with a new number, and we're setting it up here so that we don't have to hit any more buttons except enter. Okay? So we're going to take that value that it gets right there at for negative 0.5, and we're going to restore it as x. So it's going to say it's not negative 0.5 anymore, 0.5 anymore, and it's going to give us this new value. So let's see what it says. 0.2. And why in the world does that not match up with what we just said it should be? Yeah, there's why. Whoops. This should be a plus. I hope you guys caught that. Dang it. See, I do make mistakes, and that does matter. So let's go back. Okay, okay, negative 0.5. Dang, I did it again. Negative 0.5, store x. Enter. Okay, now we got negative 0.5 in there for x. I'm going to get that back Okay, so there's our formula. If you got to retype it, go ahead and retype it. Now hopefully this will give us the right thing. And yay, that should look familiar. Negative 0.3 repeating is exactly what we got right here for our next best guess. And now here's the beauty of this store X that we did. If you hit enter again, it gives you the next best guess. And I don't know why I have a 3 right here. That should be just 2 repeating. I must have messed up when I was doing this before. And we can get more best guesses. You hit enter again, it'll give us the next best guess. And you hit enter again, and there's the next best guess. So what I would expect to see on this is the next one is, let's see, negative 0.322185. I might ask you to be accurate to 6 digits. So you just keep writing, keep doing this until the 6 digits don't change anymore. And there they didn't change, negative 0.322185. In fact, none of these changed at all. And now that is correct, the correct solution to this, to 6 digits of accuracy. Okay. This formula right here that we saw is the key. Make sure you got it equal to 0, and it'll give you that every time. What do I expect to see on your paper when you do this? That was the x4, x5. There is our final answer. I expect to see x1 is negative 0.5, x2 is negative 1/3, x3 sub 3 is negative 0.32 repeating. Here's x4 and x5. You don't need to see this. I know that you've done it just by simply writing those numbers down. I mean, for your benefit, you might want to show how you got this equal to 0 if it wasn't already. You might want to write f prime of x down so you know what you were using there, so you don't make a mistake like I did when I was entering it into the calculator. But at the very least, I need to see these numbers until you get the required bit of accuracy, which will be described in the book and the problems. So hope that makes sense. Your assignment is page 242, number 6, 14 to 18, 59, 61, and 62. Oofda. See you later. Bye.